Hello, I'm Matthew Macario. Today we're going to be looking at a question about solubility. We're going to do a walkthrough on a titration calculation to work out solubility too. So stay tuned, we're going to go through the whole question. This question is a question from the AQA in the UK. It's from A-level chemistry from 2024 paper 1. The question we're going to be looking at is question 2. So let's read through the question and pick out what information we can from here. So it says this question is about an experiment to determine the solubility of strontium hydroxide in water at 20 degrees Celsius. Strontium hydroxide is slightly soluble in water. Strontium hydroxide solution reacts in a similar way to calcium hydroxide solution. And then it bullet points for us the details of the experiment itself. It says some solid strontium hydroxide is added to approximately 1 decimeter cubed of distilled water in a stoppered flask. So visualize that if you can. Volumetric flask, 1 litre of water and a small amount of strontium hydroxide is added. The mixture is kept at 20 degrees C. Every day the mixture is checked. If no solid is present in the flask, more solid strontium hydroxide is added. On the day when no more solid needs to be added, the flask is opened and the mixture is filtered into another flask and stoppered. A 25 cubic centimetre sample of the filtrate is transferred to a conical flask with a pipette and a few drops of indicator added. The sample is titrated with 0.100 moles per decimeter cubed of hydrochloric acid. The titration is repeated several times with further samples of the filtrate. Results are shown in table 1 and that is on the next page. We'll get to that. So what's going on here? The description says you start with exactly 1 decimeter cubed of distilled water in a stoppered flask. The mixture is kept at 20 degrees. Strontium hydroxide is gradually added over a several day period and the mixture is kept at 20 degrees. The mixture is checked each day to see whether there is any solid strontium hydroxide or whether it is all dissolved. Finally, when the mixture does have some solid remaining, the mixture is filtered to remove the excess solid and the filtrate, that's the solution, is put into another flask and stoppered. Let's go through the question one step at a time and talk about what the question is getting at and how we should answer in order to pick up the marks available. So, question 2.1. Suggest why the solution is kept until no more solid needs to be added. Why do we keep adding the solid until no more needs to be added? The experiment is to try and determine the solubility of strontium hydroxide, and that means we need to create a saturated solution. And it's only by getting to the point where no more solid will dissolve that you have created a saturated solution. So until you see solid remaining that is undissolved, you don't know that you've achieved a saturated solution. And therefore the answer is along the lines of to make sure that the solution is saturated. Okay, the next part of the question 2.2. Suggest why it is important to remove the undissolved strontium hydroxide before the titration. That's because we would get a false higher titration value because some of the solid strontium hydroxide would also react with the hydrochloric acid during the titration. Therefore, the titration wouldn't just be reacting with the dissolved strontium hydroxide, but also an unknown amount of excess solid undissolved strontium hydroxide. We would get a false titration result, a high result. The ways you might answer that are to say that we would get excess strontium hydroxide reacting with the hydrochloric acid, or you could say that the titration value will be high, or you could say that you need a larger volume of the hydrochloric acid to reach the end point than you should. Next part of the question 2.3. This reads, after the filtration, the solution is stored in a stoppered flask. Suggest a reason for stopping the flask. Again, like the previous two, this is for 1 mark, so we don't need to go to great details in answering this. Okay, so why do you stopper the flask at that point? What could happen to the solution? Things that could happen to the solution are that you could get evaporation, or that the solution might dissolve carbon dioxide from the atmosphere if unstoppered, and dissolved carbon dioxide would change the titration result. It's not the answer they're looking for, but it's a fair answer to say that it's stoppered so that you can invert it to make sure it's mixed. Question 2.4. So the diagrams in figure 2 show the part of the pipette with the graduation line. Which diagram identifies the pipette is correctly filled? You can see on the screen here the diagrams that show the line on the pipette and the meniscus, the top of the solution when put into the pipette. So there's 3 different options here of the meniscus position, and the question is basically asking us to identify which of these is the correct position of the meniscus that identifies we've got exactly, in this case, 25 cubic centimeters. We've correctly filled the pipette to the correct mark. So we have the one here where the meniscus tips are on the line. We've got here one where the meniscus is centered on the line. And we have one here where the lowest part of the meniscus is centered on the line on the pipette. When reading a pipette, or indeed a burette or a measuring cylinder, any volumetric glassware, it's important to line up the lowest part of the meniscus with the marked line or graduation. So in this case, the answer is going to be C, because the lowest part of the meniscus sits exactly on that line. Now we come to the biggest part of the question, question 2.5. Let's read it through and then consider what it's getting at. It says solubility can be quoted as grams of solute per 100 cubic centimeters of solution. Table 1 shows the results of the titrations between strontium hydroxide and hydrochloric acid. These can be used to determine the solubility of the strontium hydroxide. And then in the table we have a description under the column titration. We have 4 columns, so the rough titration value, the first one that would have been done. We have attempts 1, 2 and 3, and for each of the attempts, the rough and the real titrations 1, 2 and 3, we have the final burette reading, we have the initial burette reading, and we have the titer value in cubic centimeters. In other words, the difference between the initial and the final burette reading. So the question asks us, give the equation for the reaction between strontium hydroxide and hydrochloric acid, and then use the results in table 1 to calculate the mean titer, and then use the mean titer to calculate the solubility of strontium hydroxide in grams per 100 cubic centimeters of solution at 20 degrees. And the 6 marks for this, it's a reasonable chunk of a question. There's some good marks here if we know what we're looking for and can go through the calculation and present our findings correctly. So the first thing is we need to write the chemical equation for that reaction between strontium hydroxide and hydrochloric acid. And we also need to calculate the mean titer. Let's think about doing that bit. The mean titer, we ignore the rough value, and we're looking for the 2 closest values here. So these are the titer of 1 and 3. So 32.45 and 32.40. And the average of that is going to be 32.43. Let's go on and write the equation and do the calculation. The first thing that this part of the question asked was to write the chemical equation. The chemical equation between strontium hydroxide and the hydrochloric acid that we do in the titration. This is the equation for the reaction. So it tells us that 1 mole of strontium hydroxide requires 2 moles of hydrochloric acid for complete neutralization. You also got the information from the table that enabled us to calculate the mean titer is 32.43 cubic centimeters. So the number of moles of hydrochloric acid we use during the titration is the concentration times the volume. The concentration in moles per decimeter cubed, if you remember, was provided as being 0.100 moles per decimeter cubed, and the volume is 32.43 over 1,000. We have to give the volume in decimeters cubed. So our number of moles of hydrochloric acid that we required in the titration was 3.24 times 10 to the minus 3. From that, we can calculate the number of moles of strontium hydroxide that must have been in that 25 cubic centimetre sample. And it's exactly half, because for every 1 mole of strontium hydroxide, we required 2 moles of HCl. Therefore, there was half as many moles of strontium hydroxide as hydrochloric acid in the sample. And that was in a 25 cubic centimetre sample, and we're asked to find out how much strontium hydroxide is present in 100 cubic centimetres. So let's work out how many moles that is. The number of moles is going to be 4 times the number of moles that were in 25 cubic centimetres. So that's 6.48 times 10 to the minus 3. The question actually asks us to work out the mass in grams of strontium hydroxide in 100 cubic centimetres. So we need to multiply the number of moles by the relative molecular mass of strontium hydroxide, and that will tell us the number of grams of strontium hydroxide that are dissolved in the 100 cubic centimetre sample at saturation. So we can see that we have 0.788 grams of strontium hydroxide in 100 cubic centimetres of solution, and that solution was at saturation point. So this is the solubility of strontium hydroxide in water at 20 degrees. So what you need to do is show the working here in the space in the question paper. Write it all clearly, don't miss anything out. If you've worked with me or watched any of my videos before, you know that I always say that the examiner, the person marking your exam paper, can only give you a mark for what you actually write down. They can't read your mind, they can't assume your intentions. So put it on the paper and get the mark. That is probably one of the easiest ways to drop marks, is to not bother to put something, or at least not clearly. Okay, thank you for listening to this question. If you've got any questions about what we've gone through today, about the chemistry, or about how we've answered it, please write them in the comments below. Also, if there's any other exam questions you want me to go through, put those in the comments too. Let me know which exam board, which year, which paper, and which question. And then subscribe, because then you'll know when it's done, when it's published, and you'll be able to look through it. Okay, thank you. That's all from me today, but don't forget to subscribe.